Hi guys, good afternoon. Welcome. Let us try to give the others another 5 minutes. All right, good afternoon. We can begin. All right, so the last time we had some challenges and we stopped physical geography at coast. We were about to get into coastal deposition, so we're going to start there today. Welcome to everyone. I'm seeing some new people. Hello, Angel, Veronique, Mega Trending, Clark, Zoe, Rashane, Tyrone. Hi, Tyrone. Miss Smith. I think Miss Smith is new. Alicia Marie and Jablest Rastafari. I think you're new as well. Welcome. So if you're new and it's your first time or you have been here, please ensure that you subscribe to the channel. We would like that very much. You'd help us out a lot. So let us just get right into it, okay? So on the syllabus here, it shows us that for the coastal landforms, for coast, these are the ones that they want us to look at. That's what the syllabus wants you to pay specific attention to. So the last time we did live stream, we covered all of the erosional features. So we did cliff, wave cut platform, headland. We did, well, some others that are not listed here. We did cave, arc, stack, stump. Yeah, we did all of those. So today we are going to pick up at the coastal depositional features. So we will cover bays, beaches, tombolos, and spits. If you have any questions, let me know. If you have any queries, let me know. Yes, Veronique, I know that you're not new. I was talking to the other people. I know you are one of our regulars, you know. Hi, Bacchus. Welcome. So let's just look back at the PowerPoint that we were using the last time. So we were at formation of features of deposition. So again, just to recap, we know that features of deposition are formed mainly as a result of constructive waves, just like the name suggests. Constructive waves are actually waves that are constructing, they're building. So they would have a strong swash, but they would have a weak backwash. All right. So moving on, we're going to just identify the coastal features of deposition, and then we're going to explain how they're formed. So we're not doing this in deep detail because you would have done this already. We are just going through it so that you can have a refresher before your before your multiple choice exams. And since we've been doing a lot of past papers, then you would basically look at these to see how they will help you to answer your past paper questions. So Miss Smith is not new. Okay, Miss Smith. All right. Yes, I can do June 2006 next. Hopefully that will be tomorrow. Hopefully. I have been posting the answer keys on the blog as I said I would. Not as fast as I said I would, but I have been posting them there on the blog. If you're here and you have not checked out the blog, you can check it. So the explanations would be there for the past papers. There are some past paper actually there, some specimen papers that are actually there, and then the answer keys are there as well. I will try to type it for you in the chat section while we go along. All right, so these are the coastal features that are caused as a result of deposition. Bay Spit, Bayhead Beach, Barrier Island, Tombolos, Lagoon, and Salt Marsh. From what we have seen on the syllabus, we are not required to look at all of those, but we will just run past them basically. So this diagram is a little blurry, but it gives you a pretty good idea of what each feature would look like, where each feature would be, and how they basically interact with each other. So we have a bay here, we have a spit here, a lagoon which is behind this bar. We have a bay mouth bar, a little inlet for the water to come in, which gives us a bay. We have a barrier island, a beach here, a tombolo, and a sea island. So we pay attention first to where the ocean current is coming from, where the wind is coming from. We said at the last live that the wind carries the waves. So whatever direction the wind is going in, that is the direction that the wave is going to go in. And when the waves come on the shore, they are going to deposit the materials using longshore drift, which is basically a 90-degree angle up and down the coastline. So we went through all of that already. So now we're just going to be looking at the actual features of coastal deposition. So the first one is the Bayhead Beach. So beaches are features of deposition, but beaches can also be features of erosion. There are some beaches that are created as a result of erosion that has taken place. But in this case, we are just looking at bayhead beaches as a depositional feature. So the waves would deposit materials between two headlands. So there's a question on one of the past papers that we looked at already that showed us a diagram, and we were supposed to identify one of the areas that was right in the bay there. We were supposed to identify what feature it is. And we had a bay and I think a beach. I think those are or a coastal plain and a beach. Those are the two that we had. If you remember that question, you can let me know. You can also tell me what past paper it was on, if you remember as well. I think we saw it on more than one past paper. So these are the kind of things that you would need to look out for. Because you're doing paper 1, you don't need to have a lot of details about a lot of things. You're very lucky. But what you need to know definitely are your diagrams. So this is basically what your bayhead beach would look like. So you have a bay, which is basically a sheltered area. All of this area here that is basically shaped like a letter C. This would have been your sheltered area. And this area would have on both sides of it, or on both ends, you would have headlands. So one is here, one is here. So when the wave is coming in, it's going to attack the headlands first. And most of the attacking here would lead to erosion out here. But as the waves approach this area, which would be a lot more shallow and a lot more sheltered from the wind, the waves are not going to be so high anymore. They're not going to be so strong anymore. So deposition is going to take place in between the two headlands. That is how you would end up with your bayhead beach. Let me know if you have any questions about the bayhead beach, so we can just jump right into the next one. So pretty much this is a diagram that you are going to be looking for. And if you get a diagram like this, you know that this area is your beach, or you can also call it your bay, and then you would have your two headlands at the end there. Okay? Next thing that we're going to look at is a bar. The syllabus did not specify that you look at a bar, so we're just going to run through it. Let me just jump back to the diagram so you can see what a bar looks like. So this is your bar. All right, so the bars, these are linear deposits. So the deposit is going to be set basically across your beach, across your coastline. So that's a linear deposit of materials which are approximately parallel to the coast, yes. Some may be underwater, and some you may actually get a chance to see. Some you may see when the tide is low, and then other times it seems as if it disappears. So usually it starts off with just sand being deposited in that area. Once the sand is deposited in that area, more sand would come and deposit right beside it, so it would start building up. Once it gets to a point where vegetation can actually grow on it, so you start having some of those seaweeds, etc., it starts stabilizing the soil, stabilizing the sand. So once it is stabilized, it is easier for more deposition to take place right there. So it continues to develop, more deposition take place. Remember that all of these features are formed over quite a long period of time. So once you have vegetation on it, it would be as if you start seeing a new island out in the ocean. Usually it is not very, very far away either. And once you have the vegetation taking place there, then you have it stable enough. Soon enough, it may become a barrier island. Then you may have people starting to go on it, etc. All right. So this is one that we're looking at here. So all we're seeing at the moment is just some white sand, but it is in the middle of the water, not at your beach like we're accustomed to. So once this is in the middle here, it would start breaking the waves at this area before they actually get up to your beach. When it breaks the waves here, the deposition would actually take place on this bar here. So the more deposition takes place here, the higher this would become and the stronger it would become. Eventually, you would have vegetation growing on it. Once the vegetation grows on it, then you would end up with a more stable structure. Eventually, you end up with a barrier island. All right, so if you have any questions on that one, you can let me know as well. So we're gonna jump right into spit. So spit is a feature of deposition. For the spit now, there are certain things that must be happening for a spit to be formed. So let me just go back to another diagram to see if I can explain it to you clearer. This could work. So on this diagram here, so we have the wind that is coming from this end. We have the wind taking along with it the waves. And the waves would be taking along with it materials that need to be deposited. So one thing that must happen for a spit to be formed is that there must be a change in the shape of the coastline. So relating to the shape of the coastline, we have this area here. So we're seeing the coastline and then we see this drastic change in the shape of the coastline here. So since the coastline has changed its shape, the deposition still needs to take place, but it is basically going to piggyback or attach itself to the island that is already there. So you would have a small attachment being made here. So small amount of items would have been deposited right beside the edge of the island here. And then years upon years, you have more attachment taking place. So it gets a little wider. And then more attachment, it gets a little wider. The edge of the spit is usually curved just the same. So it is described as a finger-like projection. So it's almost like you're pushing out your finger and pointing it out, and then you curve it at the end. So that is what your spit would look like. So if you get a diagram where you're supposed to identify the spit, one, you look for a change in the shape of the coastline. Look for the extension like a finger, and then you look for a curve at the end. That would have been your spit. From time to time, you may have a spit like this actually growing across the entire bay. Other times, there may be a change in the shape of the coastline, but a spit cannot be formed in that area. Okay, so there is one called Morpion Island in St. Vincent down in the Grenadines. Very good. Cool. So there are times where you may have a shape in the coastline, but you cannot have a spit forming there. One of the major reasons for that would be if there is a river. If there's a river that is going to be depositing materials into the ocean, the river would also be letting out a lot of water. So it would be difficult for the spit to form across the area when the river is discharging so much material in that area. So the spit would not form at that area. All right. So we're back at spits. Let's just see if we missed out anything. They're usually linear, connected to the land at one end, and they are free at the other. This is important for you to remember as well, because we have another thing. We're going to tell you the name in a little bit, and I'm going to show you as well. We have another one that extends just the same, but it may connect to another island. If it connects to another island, then it is no longer called a spit. It is called something else, which is a tombolo. So spits, they're connected to the land at one end and they are free at the other. They usually form where there is a bend in the coastline. So we said that one already. Formation of a spit. This is a better example here. So we have longshore drift. This is the direction. So we have that zigzag pattern. Materials are being moved up and down the coast. Yes, they're still being moved, and then you have a change in the shape of the land or change in the shape of the island. So because there's a change in the shape of the island, the deposition starts taking place right on the outside here. As a result of this, you will have this area deposited first, and then you have your curve like a finger, and then continually more material is being deposited. So you end up with that larger extension that is attached to the land at one end, but out or free at the other end. Let me know if you're understanding. So once this happens, there is no longer water, the seawater is no longer able to get behind this area. So this area now starts having a little vegetation growing on there. So we end up with a salt marsh. The syllabus does not ask us specifically to look at salt marshes either, but it is something that you can just keep in the back of your mind. Here, it's just what we just spoke about where the river is. So because the river is depositing material of its own, then it is difficult for the spit to continue forming here. It's difficult for the spit to continue growing any further. So it is going to curve and then it would stop at that end. All right. If you have any questions on spit, you can let me know. This would have been an actual example. Then we jump into Tombolo. So the Tombolo linear deposit just the same. Materials are formed by longshore drift just the same. But the difference with this one is that it extends, then it joins an island to a mainland. So the mainland would have been where we were initially, where the spit started from. And then you would have had that island out in the sea, and it would have this attachment that was created would have touched this island. So there are many of them, as a matter of fact, where after the attachment has taken place and then you have constant deposition as well as vegetation growing on it, it becomes so stable that people actually start driving on it, building a road on it, etc. to get to the other island. For a spit, for example, the Palisades in Kingston, Jamaica, where our airport is, it is actually on a spit. So they can grow so strong and become so firm that you can actually build on them, and it's fine to do so. I'm seeing another example for Scott's Head. Veronique, could you tell us where Scott's Head is? Hello, Jasmine and Camille. All right, so this is the example of the Tombolo here. We see the longshore drift happening just the same. We see the change in the shape of the coastline, and then we see the spit that has grown out. But once it grows out and then it now attaches to another island, it is actually called a Tombolo. So you can, I don't know if you can picture this with vegetation on it and then somebody cutting a road on it and then eventually somebody driving across going on the other island, and then this becomes this lovely private island or one of those party islands or one of those expensive islands that a hotel would buy or something, and then persons are not privy to going on there. Something to that effect. That's the picture that I have in my head. So you can tell me what kind of picture you have in your head regarding this as well. But I think it's a really cool thing for you to actually join these two together. So we'll move on if there are no questions or no queries. Still waiting for Veronique to tell us where Scott's Head is. All right, so this is an actual real life example here. So here's our mainland. And then here is our change in the shape of the coastline. And then we have our spit extends until it actually meets this island here. Eventually, I'm thinking that all of this area will be deposited and it will just become a larger extension of the actual mainland. So we're at salt marsh. Oh, this not specifically on the syllabus, but we kind of just went through it. So water becomes trapped behind a spit. It creates a low energy zone. Water begins to stagnate simply because it is not being exchanged as much as it used to be exchanged. So the waves are not coming in and taking out and coming in and taking out. So the water begins to become a little smelly, and then you have the mud there, and it causes a marshland, and vegetation starts growing in that area. Lagoon, a spit may continue to grow until deposition can no longer occur. For example, due to increased depth, or the spit begins to cross the mouth of a river like we saw, and the water removes the material faster than it is deposited, so it cannot build up in that area either. At a bay, the bar as well, if it continues to be fed by the sediments, or if more sediments become added to it, it will extend across the bay, which will form a lagoon. So the lagoon is basically a nice protected area that is now protected from the harsh waves that would be coming in. So the lagoon is good for some species to breed and reproduce in that area. Turtles would use a lagoon a lot. And some of those in the Caribbean are protected areas just because of the of the role that it plays to the different species. Okay? And now we're going to look at the formation of a bar. So for the bar, we see the direction of longshore drift again. Materials are being deposited all the way across the bay here, and it basically cuts off the bay. We end up with an old bay. Behind that bay, we end up with what is called a lagoon. So you can look at the diagram there. All right, so Scott's Head is in Dominica, okay? All right, so let's move on. So we understand the formation of a bar. This is a nice diagram that I like to show. So we can see the sand spit that is here. We can see the vegetation on it as well. Longshore drift is going in this direction. So this is where your features are going to be formed and where the extensions are going to occur. Silting is taking place behind the sand spit here. So you have mud being created in this area. So eventually this area will become your salt marsh. Once it extends across the entire bay, you end up with a lagoon here. And once it extends and touches an island, you end up with a tombolo. So that is basically a synopsis of all of what we just went through. Okay? So that would have been it for our features of deposition. If you have any questions relating to features of deposition, you can let me know. So we are going to look right back at our syllabus now. So on our syllabus, we would have finished the landforms, and yes, we covered all of them. So now we would be moving on to number 23 on the syllabus. Went a little bit too far. So we'll try to finish all of natural systems, and then we will go through human geography so that you can have everything covered before the actual exams. So next thing we would look at would have been the drainage patterns. So for drainage patterns, there is an actual video on drainage patterns that describe the drainage pattern in relation to the rock type and the geology of the land. That video is already posted on YouTube on the same channel, so you can look for it. I'll just run through it just the same. There are three main patterns that you are expected to look at. The three patterns are dendritic, trellis, and radial drainage patterns. So for those three, they are relating to your rock type and they have a specific shape. So dendritic is from, I think, the Greek word. I think it's a Greek word. I don't remember, but it means tree, like Tree. So it means tree, so it actually has the shape of a tree. So if you are picturing the drainage patterns, then if you'd like me to just skip to the video, you can let me know. Or if you'd prefer if I just keep talking about it, just let me know in the chat section. So for dendritic, it is shaped like a tree. And it is pretty much what we would see in the textbooks when we are describing rivers, when we are drawing rivers and labeling it to show the tributaries, etc. It is usually the dendritic pattern that is shown. So you would have several different, let us say, branches for the tree, or in terms of the river, we're talking about the tributaries. And then you would have the bark, which would have been the tree bark, which would have been your main river that everything is joining into. The next one that we would have been our trellis pattern. All right, so somebody's asking for me to do the video. Let me just jump into it really quickly. So talk about it first, then do the video. But the video explains it clearly. So I will just try to, let me see if I can just attach it right here so we can just look at it. So for trellis pattern now, trellis is more of a, I don't know if you know those, what is that called? It's like a thing that some persons have in their yard, and it's like a parallel shape with little rectangles. Some persons use it as fencing. Some use it as fencing. Some use it as things to grow plants on the outside. I think there's a diagram for it in the video as well. I think there's a diagram for it in the video as well. Let me know if you are seeing the video. I'll try to cut out most of the little talking.
Hi guys. So, thinking of the topic drainage patterns, my first question would be, what is drainage? And then that would bring other questions into my mind. When I think of drainage, I think of water running, or the word drain. For water to run, there needs to be a slope, that is highland and lowland. And based on the laws of gravity, we know water would run from the highland to the lowland. In river systems, though, drainage refers to how water runs off the land. This would include streams or tributaries running from different directions to join or to form at a main river, which later flows into a larger water body such as a lake or the ocean. The entire area of land where the water is running from to join the specific river would have been called the drainage basin. This can also be looked at as a catchment area. In this case, our catchment area would have been this entire area here in red. Now think about it this way. Think of a large pan or bowl that is placed outside during the rain. All areas inside the pan, that is the sides, the bottom, would make up the drainage basin. So for this specific area, this would have been our drainage basin. But we have to consider the other areas as well. If we have another pan placed right beside it and another pan placed on the other side of it, those areas would have been catchment areas, but they are in other drainage basins. So in this diagram, we have 1, 2, and 3 separate drainage basins. At the top of the bowl, or where we have our red line here, where the water can run off into another drainage basin, we would call that area our watershed. In this diagram, it is labeled as our divide. So then this brings us here. What are drainage patterns? When we think about it as well, patterns would be a shape. So we are looking at the pattern or the shape that the river and its tributaries create when they are running off the land. The pattern is usually formed as a result of the structure of the rocks that are in that specific drainage basin. Today we will be looking at 3 types of drainage patterns. Those are radial, dendritic, and trellis pattern. For our first pattern, it is radial. This is a circular pattern where water is running from one main central high point here. Since it is a high point, it is almost as if water is overflowing and will therefore run out in all different directions around the peak. These create a pattern that looks like spokes on a bicycle wheel. So this one is basically circular, and an example is Safrere Hills in Montserrat. This is a more realistic diagram of a radial drainage pattern where you can actually see the peak and you see the areas where the water is running off the land. Pattern is the trellis drainage pattern. This is a rectangular pattern where water is taking turns at right angles. Rock type here is very influential in the trellis pattern. It occurs where there are alternate bands of hard and soft rock, where soft rock is easier to erode, so tributaries will form in the soft rock and join the main river at right angles. An example of this is Bay of Fundy in Canada, and we can see here what the trellis pattern would look like. This is a more realistic view of the trellis pattern. You can see the ridges, different types of rocks where the water goes through accordingly. Our third pattern is the dendritic drainage pattern. It is from the Greek word dendrite, which means tree. So the pattern itself actually resembles the branches of a tree, and they develop into gently sloping basins with a uniform rock type. The tributaries flow into each other from any area because the rock type is the same throughout the entire area. One example of the dendritic drainage pattern is the Caroni River in Trinidad. This diagram shows a more realistic look of the dendritic drainage pattern. Alright, so here's a summary. The drainage pattern radial, it has a circular shape. It is usually found around volcanic rocks where there is a peak. One example is Safrere Hills in Montserrat. Trellis pattern, it looks rectangular as they're forming at right angles. Rock structure, it usually has alternate bands of hard and soft rock. One example is Bay of Fundy in Canada. The final one is the dendritic drainage pattern, which has a tree shape. It has uniform rock structure. And one example is the Caroni River in Trinidad. Now it's question time. What drainage pattern does this?
All right, so let me know if you get it. Let me know if there are any questions relating to the patterns that you just saw. Pretty much that would have covered that one objective in its entirety that we were about to look at. That is 23 here. So let me know if you have any questions relating to the drainage pattern. So the video explained the 3 types. It also explained the relationship to the rock type and the geology. So in my head, that was very clear. So if you have any questions though, you can still let me know and I will help you out. All right. So Lillian says we're good. Okay, cool. Right. So if there are no questions, we can just move on to coral reef. So that would have been our next thing on the syllabus. So types of coral reef, fringing, barrier, and atoll. It also asks you to look at the conditions necessary for the successful formation of coral reef. These are the conditions that they want you to look at specifically. That's the depth, salinity, temperature, turbidity, presence of beneficial algae and fish. They also want you to look at the importance of coral reef in terms of coastal protection, raw materials for beaches, ecological and economic benefits. So we're going to just look at objectives 24, 25, and 26 all together. Okay? Yes, Bacchus, there is one called parallel drainage pattern, but the syllabus does not ask us to look at that one specifically. As a matter of fact, there's more than the ones that we have listed, but the syllabus specifically requires us to look at those 3. So your questions that you're going to get will be on those 3. Potential questions for those on your paper 1 exam would be where you would see a diagram and you would be asked what kind of drainage pattern is shown in the diagram above, and then they give you the names of the drainage pattern and then you're supposed to pick the correct one. So basically you can look for a bicycle spokes looking one, or you look for one that is shaped like a tree, or you look for one that is shaped like the lattice. Then you would know which one it is. So there is something in the real world for you to just tie it to in your brain, so it helps you to actually remember what it looks like. You may also see a question asking you about drainage pattern in relation to geology or in relation to rock type. Remember, it's multiple choice that you're doing as well, so it would be easy for you to just pick your answer based on the video that you just saw. So I sent the link in the chat as well, so you can check on it. If you want to look it back over, that is also fine. You can go ahead and do that. Please ensure that you like the videos as well and subscribe to the channel, so it makes things very, very easy for us. The last time we had a crash course, the crash course crashed. My cell phone was working perfectly though, but I can't use my cell phone yet until I have gotten to 1,000 subscribers. So we're close enough. Hopefully we can get there before your exams, so I can do some whiteboard work, drawing work, and get on that for you. All right. So we're going to look at coral reef now. So this is coral reef. This PowerPoint was actually made by the Montego Bay Marine Park. My students, well, we visit them a lot. So every year I would take down a group of students. We do a boat tour of the coastline. I would point out all of the features to them, all of the features that are formed along the coast. So they get a chance to see a blowhole, they get a chance to see the caves being formed, the cracks in the face of the cliff. They get to see the beach. What else? They get to see groins, sea walls, etc. So that's what we normally do with the Montego Bay Marine Park. And after the boat tour, sometimes we walk along the coast so we can collect information for them to go ahead and do their SBAs. So these are our objectives. We're going to identify the types of coral reef. So these objectives are pretty much similar to what the syllabus had asked for. So it covers everything that the syllabus had asked for. So we're going to just run through. These are terms that you need to know. If you don't know these, check on them because they might pop up somewhere on your exam. All right. What is a coral reef? So they are, well, we know in our head what they are. So they are very diverse ecosystems. We have many different species utilizing that area. The ecosystem is made up of tiny living animals. Those are what are called corals. So the corals are actually alive. They are soft. They do not move, and they do not have a backbone either. When they die, they leave behind the hard structures which actually form the reef. So coral reefs, it's like the rainforest of the sea. We have 30 different kinds of whales, turtles, fish, snakes, sharks, stingrays, blah, blah, blah. Lots of different types of things. It's also home to the largest clam in the world, so that's a fun fact. Algae live on the corals, and through photosynthesis, the corals steal nutrients from the algae, giving them their vibrant colors. So this is basically explaining a relationship between the algae and the coral themselves. So yes, they benefit each other, but at the same time, if you have too much algae, then you would end up in problems for the coral. So, all right. For some people, SBA, they climbed up through a river and had lunch, but that's cool too. That's nice. I'd like to do that. And you went on a farm. Cool. Yeah, we also take our girls on farms as well. So sometimes they get an option. They can pick different things to do. So we would take them on trips at different places, and then they would collect all of their data for the SBA, and then they can work that through. I'm also going to be doing a video of the actual data collection. So when persons are doing their SBAs, it's a little easier for them, and they will know how to collect the data, what kind of data to collect, where it's best to collect the data. So they have a pretty good idea of how to structure their SBA. So you can tell your grade 10 or Form 4 friends to ensure that they subscribe to the channel as well, so they can get some more information. All right, so coral reef, we already went through a lot of this, so we don't have to. We can look at this one though. Microscopic algae live within the bodies of the coral animals and provide food for them. The algae requires warm temperatures and sunlight. Coral reef can only be formed in shallow tropical waters. Right, this is always a hit with the students for some reason. I guess they've always been hearing that sand is fish poop, but in a way it kind of is, but it is also kind of not ish. Yeah, very indecisive there. The parrotfish will grind up the broken coral inside their bodies. They produce the fine, soft sand, and then they poop it out, and that is commonly found around the reef. So the entire thing is not fish poop. We would have learned enough by now to know that it is erosion from cliffs, etc., that would produce the material that is deposited on the beach, but there is also some amount of it that came from the parrotfish area. All right. Hello, Jones. Okay, so that's the coral polyp. We don't have to look at that. Global distribution of coral reef. We pretty much know where they are. They are in our warm Pacific tropical shallow areas. Conditions necessary for the formation of coral reef. Now, these are important. This can pop up by itself in a multiple choice question. We did see one, I think maybe on the 2018 paper or the 2019 paper. It actually gave you some things and asked you which one of them is not. Which one of them is not necessary for coral reef formation? Something like that. Or it asks you which one of them is necessary for coral reef formation. If you remember the question, you can let me know. But that question is definitely on either the 2018 or the 2019 paper. So, conditions necessary. You need shallow waters with the right amount of salt. So, one, the water has to be shallow and it has to be clear and clean so that the sunlight can pass through the water, so that the sunlight can photosynthesize with the algae so that you can get your nice, beautiful coral colors. So the depth for that is about 55 meters. I think the textbook said 45 meters, but based on the individuals at the marine park, they have been seeing at 55 meters. So that's why they had placed it in this PowerPoint. They thrive best in temperatures between 20 to 27 degrees underwater. That is in our tropical areas as well. They develop between 30 degrees north and 30 degrees south in the tropical regions, especially on the eastern side of land masses where warm currents flow near the coast. And the coral reef, the water that it is growing in, also needs to have the right amount of salinity, that is salt water. So that can also explain to you why it is that we would not have coral reef forming at the mouth of a river, because the river is freshwater. And if you have the freshwater going into the salt water, that area where the freshwater mixes with salt water, it has a specific name that it is called. Can someone just tell me what the name is in the chat? I will not tell you what it is. I'll just wait until someone figures it out. So that is where the salt water meets the fresh water. What is that specific area called? But in that area, we would not be having any coral reef being formed because the coral reef would need the salt water. All right, so I'm hearing that it is the June 2018 paper that this question was on. So you ensure that you know this because you don't know if you will see it again. Reasons why reef are not widespread near the mouth of rivers. So one, sediments carried by rivers would choke the tiny coral polyps on the surface of reef. So the corals, they're alive and they have small tiny holes that they would breathe through. And if you have sediments coming from the river, sediments that we are unable to see. Remember, we looked at river sediments and how they transport their material, and we know that some of that material is transported in solution, so we can't necessarily see it, but it is there. So some of these tiny things would actually choke the corals, and when they choke, then they would die. So I'm seeing two answers that it is called a front. No, that's not what I'm looking for. It starts with the letter B. It starts with the letter B for when that fresh water mixes with the salt water. What is that area called? Next one, fine sediments stay in suspension or they float in the water and they reduce the penetration of the sunlight. So remember that the sunlight needs to pass through the water in order to get to the corals so the photosynthesis can occur. if you have the sedimentation floating around, remember we discussed that as well, the suspended load. If you have that in the water close to the mouth of the rivers, it will block the sunlight from passing through, and then you will not be able to have the corals growing properly. So we have a winner. We have Jelani Holloway getting it right. That is brackish water. And actually, you know, it is actually right here on this slide that we're looking at. Okay, so Veronique saw it. Good job. So very nice, Holloway. You got it right. So we are at the third one. Water at the mouth of rivers is too brackish. That is, it's a mixture of salt and fresh water. So this brackish water cannot accommodate the coral reef because they actually need straight salt water. Good job. Final one, the temperature at the mouth of a river may not be ideal for the growth of corals. When you go to the river, guys, what is the temperature normally like? It's a little delayed, so I will not wait for you to answer that. I see more people coming in with brackish answers after, I'm going to just say after they have seen it on this slide here. But either way, good job. So when you go to the river, the temperature, it's normally colder. It's normally cooler than anywhere else. The river is just awesome. So at the river, that temperature for that water is going to be cooler. So when you have that cooler water that is constantly flowing out into the different temperature of your ocean there, it is too problematic, or it fluctuates too much for the coral reef to actually grow there. So I'm seeing Tyrone saying it's usually cold. Yeah, it is usually cold. So that is one of the other reasons why you will not find coral reef close to the mouth of rivers. So if you get a multiple choice question that is asking you, that it lists a bunch of things and it asks you which one of the reasons does not indicate why coral reef are not widespread near the mouth of rivers, you should be able to read through and figure out exactly which one of them does not fit in that answer. Next, we're on to the importance of coral reef to man and the environment. All right, let me tell you something. Whenever you get a question that asks you for the importance of anything to man, think about yourself. 90% of the time, or all the time, human beings would have used that thing to earn money in one way or the other. So if you're thinking about importance of coral reef to man, first thing is that we use it for tourism. So there are economic benefits from the coral reef because people use it for sightseeing. We can see them listed there, snorkeling, etc. So the tourists would come and see that. So that would be economic benefit right there. The other one is that the coral reef offer protection to the coastline. So when you have the coral reef further out in the ocean, remember when we were looking at the features of deposition and we saw the bar that was parallel to the coastline, that bar, just from looking at it, you would realize that the waves would already break on the bar before they get to the coast. Similarly, with the coral reef, the waves would already be breaking on the coral reef before they actually get to the coast. So it's like a barrier out there before it comes to the coast. It's like a line of defense. That is your coastline protection that the coral reef offers. Next one is that it is a feeding ground for fish, habitat for fish. So coral reef, when you look at them, there's always some amount of fishes around or some sort of species because they live there. It provides spaces for them to hide from their predators. It provides food for them because other smaller species are living there as well. So it is a very good place for them to stay. So it's a habitat for fish. It's a feeding ground for fish. Coral reef are important because they protect our beaches. They also assist in the formation of the sand, the small fine sand that the parrotfish would help us with. And then there is the medicinal value. So for medicinal value, coral reef does a lot of things. There is a lot of research relating to what coral reef can offer. So that is what the medicinal value is talking about. All right, so we don't need to go through those. We're going to go to the types of coral reef now. If you have any questions about the importance of coral reef or the conditions necessary to form coral reef, you can just type it in the chat and let me know. I will answer that. Again, if you are on the live and you have not subscribed, please go ahead and do so. It helps us a whole lot. We would like that very much. Also, ensure that you like the video. That's appreciated as well. And if you have other questions, just ask them so we can help you through it. All right. Types of coral reef. So there's barrier, fringing, atolls, and patch. Syllabus asks us to look at barrier, fringing, and atolls only. In my opinion, atolls are just the coolest of them all. They are very beautiful. I don't know what textbook you use in your country, but in the textbook Geography for CXC by Guinness, there is a very large, beautiful atoll on the front of that textbook. So once you remember the front of your textbook and you remember the shape of that one, you will know exactly what an atoll looks like. It is very pretty. So that would have been the circular one, but we're going to get through each of them. All right. So 3 main types. We have the barrier reef, we have the atolls, and then we have the fringing reef. So just by looking at them and using up your English language and your context clues, you can figure out what they may be like. So the barrier reef, it is a barrier. So just like our barrier island that we had when we were doing depositional features, it's parallel to the coastline, just the same, parallel to the shore, but it is separated by a channel of water. So you have water in between the coast and the barrier island. So that one is going to be parallel and it is basically offshore. Then the atolls now, it's a ring-shaped coral reef consisting of a coral rim that encircles a lagoon. Remember that the lagoon is an area that is basically cut off from the rest of the ocean. It could have been a bar that has grown across a bay or something like that. But in this case, it would have been the coral reef that have formed a ring shape all around. So it creates that lagoon in the middle. And finally, we have the fringing reef, which is just like the word fringing. Fringe sounds like it itch on. Let me know if you understand what itch on means. Itch on means connected to, attached. That's just the patois for attached or connected to. So fringing, when something is fringing, it is attaching itself to the land. So that means the fringing reef would have been closer to the coastline than the barrier reef, which would have been further offshore where there is a channel of water in between it. Okay, let me know if you get what I was saying. So we're moving on. This is a clearer diagram for you here. Fringing at the top, here is the reef. We can actually see the reef here, so it's actually attached to the land. The atoll, you can see the circular one here, and then we have the atoll, which is further out here, which would have formed that circular pattern. Okay, yeah, it's the same thing that's over here. And this is just giving you another view as well to assist you in ensuring that you understand. Threats to coral reef. All right, we know this from, as Caribbean people, we would talk about it a lot and we would hear about it probably on the news or just from people talking about it, etc. The main causes of destruction of coral reef it is as a result of something that we have done as human beings. So the main causes here are overfishing and global warming. All right, so this picture here is asking you to identify what is causing the destruction. This is an anchor from a ship that was actually dropped right in the middle here, and this would have torn out the coral reef. And yes, I'm seeing Veronique here giving us a response for this one over here. We have dynamite. So this is a fisherman that would have probably just thrown a dynamite in the water, and that would have destroyed everything that is around it, not only the fish that he's trying to get. So that would also destroy the coral reef. So those are very, very dangerous. Other causes here, we see people stepping on things. It seems as if they're snorkeling here as well. They're snorkeling here and they are breaking off with their hand here. But in this picture, they are actually stepping on it. So again, it's just human beings being ourselves and doing really bad things that harm the environment. So we have listed more causes of reef degradation. Untreated sewage discharge. There's a question on, I don't remember if it's one or two papers, that ask about overgrowth of algae and what would be the cause of the overgrowth of algae. And then they listed a number of things for you to choose which one would cause the overgrowth of algae. So, and the answer for that one was the sewage, because the sewage would have increased the rate of growth of the algae, which would cause it to overgrow, and then it would block out the corals entirely. Next one is tourism related activities, which is what we just saw in the slide before. Coastal development. I know, and I'm thinking that you know in your island as well, that once we start developing on the coastline, first of all, the noise is going to drive the fish away. And the sediments from the concrete or from the cement that they're using that goes into the water, all of that is going to start damaging the coral reef itself. The sediments are going to block out the sunlight. Photosynthesis cannot occur. Coastal development means that there may also be some amount of dredging taking place, and that dredging will also disrupt the coral reef ecosystem. So overfishing is another one. Natural disasters from hurricanes or storms, damaging fishing method, example, the trawling or the dynamite fishing that we saw earlier. Inland pollution and erosion, that is from industrial as well as agricultural waste. So you know that based on the hydrological cycle that we did, and we looked at the runoff from the land, we saw how the inland pollution or the agricultural pollution, the chemicals, etc., they tend to find their way into the ocean. So that is another way that they can be degraded. And I'm seeing oil spills from Tyrone as well as from Bacchus. Very good examples. Consequences of the destruction. So what happens after we destroy the coral reef? If we destroy the coral reef, it is going to cause coastal erosion. So hold on. Remember all of the benefits of coral reef? It's a little far. I think I passed it. Right. The importance of coral reef here. When you're looking at the consequences of disrupting coral reef, it would be the fact that these things that were important, you no longer have. So if you remember things that are important to coral reef, it means that in your head, you already know the consequences of destroying the coral reef. Look at this one, for example. Reefs are valuable to tourism. That means a consequence for destroying coral reef is that tourism would decline. or the economic value placed on tourist activities would decline. Coastal protection here is an importance. It means that if it is destroyed, you would no longer have the coastal protection. Habitat for fish, it means you no longer have the habitat for fish. So they go hand in hand with each other. So once you remember these, then you are good to go for these. Okay, so you would have a decline in fish stock. If you break up somebody's house and they have nowhere to live, they're gonna find somewhere else to go. While they're going there, they might die, but they will still find somewhere else to go. They're gonna leave. So you will end up with a lot of migration taking place. So that will in essence decline the fish stock that the fishermen are able to catch. And then you will see a lot of spin-off things where the fishermen start trying to go further out at sea to catch fish. And then other spin-off things where they start get caught in storms or disappearing or things like that. So it's the little things that we do sometimes that create bigger issues. Next one, coral degradation may result in coastal flooding. Remember that the coral reef is basically acting as our little line of defense out there, or defense system that is blocking out those strong waves. If we remove those, then we will have more strong waves coming all the way to the coast, which will result in the coastal flooding. Next, we have limit source for economic development in ecotourism. So yeah, we looked at that as well when we were looking at the importance of coral reef. If you have any questions, let me know. Everybody seems very quiet. I can take that quiet to mean that you get it, but it could also mean that you don't get it. So just let me know, okay? Measures used to protect the reef. You need to conserve water. You should help reduce pollution. For fossil fuels from cars help to increase ocean warming. When the ocean is too warm or global warming, that will cause coral bleaching. So they will actually die. Use ecological or organic fertilizers. If you are not using organic fertilizer, well, whatever fertilizer you use, it's going to go in the soil, and then it is going to make its way, whether through infiltration or surface runoff, it's going to make its way to the ocean somehow. When it makes its way to the ocean, it just depends on what you used. That will determine what kind of effect it will have. So if you had used organic fertilizers, I'm talking like you're all farmers, but you might be, or you might be when you grow older, or your parents are, I don't know. But for farmers, if they use organic fertilizers, then it will have little or no effect on the coral reef ecosystem. But if they're using those pesticides and insecticides and all those other words that we cannot pronounce with the hazardous signs on those bags and stuff, when that gets into the ocean, it is detrimental for all of us. Next, dispose of your garbage properly. There is another question on the past papers that we have looked at that asked us what's the best way to dispose of your garbage to ensure something I don't remember about to ensure that it does not cause water pollution. We saw the question a lot. I just don't remember the exact question. If you remember it, type it out, so somebody that did not see the question, they will get a chance to see what the question actually looked like. So for that one, it gave you some options like what's the best way to dispose of your garbage. So they gave you the option to throw it at a secluded spot, to dump it in the river, I think, something like that. And then the correct answer was for you to bury it, because it said organic waste from your house. So that would have been the correct answer for that one. But we did it in some of the past papers before. Once you have watched them, you would have met up on it somehow. Right, so I see Lillian remembers. It said to cover with dirt. That was your correct answer. All right, another way you can protect coral reef: plant a tree, practice safe water sports, volunteer to do beach cleanups. Guys, I know this is revision, but I am an environmentalist, and beach cleanups are something that you can do on your own. Wherever you live, you can just get a group of students or a group of your friends one early Saturday morning, and you just get some gloves and some garbage bags, and then you go to the beach, and then you just pick up all of the rubbish that you see. It helps you in the long run by helping the animals that are in the ocean. It helps the ocean itself in the long run. So it is something very, very good to do. And when you do it, you actually feel really nice in yourself. Nobody cares about you feeling really nice in yourself, but it feels good to be assisting where that is concerned. All right. So yeah, so Tyrone did beach cleanup, and he said it was nice. It's very good. It's something that you can look into. All right. So somebody's asking, how does conserving water protect coral reef? When you conserve your water, when you use your water, the water must be coming from somewhere else. There are some islands that practice desalinization. So they actually suck up the salt water, remove the salt, and use that in their homes. Another thing is that some countries will need to suck the water from somewhere else. They may need to access the groundwater that is there, and that requires them to actually pump the water up to take the water so that you can utilize it in your homes. When you use too much water, it means then that other persons are expected to get the water from somewhere else to give it to you. That is why you need to conserve the water. As conserving the water, it's like a domino effect. Conserving the water will assist you in helping the coral reef. Somebody's saying that the seaweed is too much. Can't help you with that. I don't know what to do about those. I don't like how they feel either. And then yes, we need to take care of the world for real. Yes, Haven, that is good. Hashtag save the turtles. All right, practice safe water sports, volunteer, and educational campaigns. So you can do educational campaigns in your school. There may be some ways where you see educational campaigns taking place on television. In Jamaica, we have one that says, "No dirty up Jamaica. Please don't do it." There's a very nice song, and then there's a very nice cartoon video that is shown as well. So it's very catchy. All the children know it. So it is something that they basically keep in the back of their minds. Canoan Island in St. Vincent have desalinization. Very good. So see, that's where they would be getting their water from. And someone else is telling us that that was the 2016 paper that question was seen on. So measures to reduce the impact. Okay, we have in Jamaica here, but these can be utilized in other countries as well. You can tell me what your country is doing specifically to reduce the impact of coral reef degradation. So some countries sign to an international protocol that basically expects them to behave a particular way or do things a particular way in order to protect the environment. I'm trying to remember one of these protocols now, but I can't. There are some that are a long time ago where the governments have signed, but I can't remember one off the top of my head. I know that there's one for mangroves that they have signed where we're asked not to remove the mangroves, but if you know the name of any right off the top of your head, you can let me know. All of what I'm talking is really just talking out of my head, not necessarily looking anywhere. So if you remember, you can just send it and let me know. Oh my, Tyrese, you've never seen a coral in real life? Where do you live? Because I'm sure there is one somewhere that you can at least get a chance to look at. Let me know what country you live in. Another thing that we have done is marine protected areas. I figure all Caribbean islands have that. So we have, remember I spoke about the Montego Bay Marine Park? That is one of the protected areas. So they would actually give us a tour of the protected area. That is in Mobay. There's one in Negril. There's another in Ocho Rios. Awareness and educational campaigns. Remember, I just spoke about that No Dirty Up Jamaica campaign with that catchy song and that nice cartoon video that is shown on television, so everybody would see it and everybody would become aware. Then you have management programs. So natural features such as mangroves provide good protection. So what we did last year. Oh, you're in Guyana. Oh, maybe it's because of all the rivers that you have. So it is difficult for the corals to actually get a chance to grow and thrive. For the mangroves though, what I did with my students at school last year, we actually got some baby mangroves that we took care of. We grew them up so that in the schoolyard in plastic, but they were in sand and we would water it with salt, with seawater, just the same. So we basically grew them up where they were big enough, and then they were tagged, and then they were replanted. I know that we were not the only school that did it, but there were other, I figured there would have been other schools that did it as well, and then there was a big replanting of the mangroves. So that would be good for other countries to do to reduce the impact on the environment. And the final one is using environmentally safe practices. If you have any questions, again, let me know. Tyrese is brokenhearted. Hush. When you leave Guyana, if you leave Guyana and you're going to go to university somewhere else, then you can always visit Jamaica to see our corals. They're very nice. I'll upload one of well, it's the same thing. You will just be seeing it on pictures. So, sorry. All right, so this is how human activities can impact coral reef. So, this is before where you're seeing nice colors over here. And then this is after where you are now seeing basically just white and it looks like a dead area. And you can see in this area here, everything is white. There was a question on the past paper as well that asked about how do you know that corals are healthy? If they have a very white color or if they are very colorful, something like that. But there's a question like that out there. So once they are very, very white, that means they have been bleached and they are dying or they are dead. All right, so Lauren, Barbados has coral reef. I've seen coral reef in Barbados. So you just need to get, I don't know, somewhere out there and try to see one. Ask one of your teachers to do a class trip or something where you all get a chance to go and you can all get a chance to see it. And if you're bringing a lot of persons, then generally it should have been a lot less expensive. So Tyrese has seen that question before, asking about the coral bleaching. So it should basically, the answer, if they're asking you about bleaching or corals unhealthy, it is the ones that are white. If it is colorful and pretty, then it is healthy. So color mean health in this case, and then the white ones would mean that they are bleached or they are dying. Okay? That's it for coral reef. Let us see what else we have on the syllabus to cover. So on the syllabus, we would have been at importance of mangrove wetlands, coastal protection, ecological and socioeconomic benefits. So those are the importance that the mangroves would provide. I have a PowerPoint on it somewhere. Can't remember where at the moment, but there is one. So we're just going to look at the syllabus to see if we can just work through that. In the meantime, so we know that we know what a mangrove is. We know what they look like. We know why they're important as well, based on what is listed there. And we also know that exactly where the mangroves would have been formed based on what we just went through for the features of deposition. I'm still trying to find that mangrove PowerPoint to see if I could just pull it up for you, but I do not see it. So we're just going to go ahead and leave it alone. All right, mangrove for coastal protection. So based on where the mangroves would have been, the mangroves would have been blocking out, or they would act as another barrier or another line of defense for protecting the coastline. If you remove the mangroves, then that would mean that you are removing the protection that the coastline would normally get. So the mangrove would have been the area where you would have the brackish water, and it also have the different types of mangroves. So based on how the roots of the mangroves are, the roots would block things from actually entering onto the land. So it would reduce the wave completely before it actually enters on the land. So it would reduce coastal degradation very, very well. And it would reduce coastal erosion as well very, very well. Mangrove wetlands, they also have ecological benefits. They are very, very important as a habitat for different species. There are several different species that live in the mangroves, and that's just their place to be. There are crabs, there are snails, there are different types of fish, there are birds. So you have both land and aquatic animals that live in the mangroves. So it's very important to keep them. The other one is the socioeconomic benefits. So there are persons who would want to visit the mangroves in order to learn about it for ecotourism, etc. In Jamaica, we do the Black River Swamp Safari Tour. You basically would go down the river along the mangroves. You would see all of the animals, all of the insects, and you basically see how they interact with the natural environment. So that's a good tour for persons to do as well. If in your country you have any of those mangrove areas, let me know. I think it is Barbados, near the Graham Hall Bird Sanctuary, I think. I think there was a mangrove area there. I went to that place. It was a nice sanctuary, lots of birds, hundreds of birds. But I think there was a wetland somewhere. Just what the trees looked like, they look like it's a part of a wetland. So if you're from Barbados, just let me know. Mhm, mhm, mhm. Uh, Bacchus is asking, you want me to send for you? You can find Irish. Okay, the Irish moss thing that some persons they drink it or they cook it, but it tastes nice, you know. It's just some persons call it sea moss or other persons call it Irish moss, but it tastes good. It's mostly men that would drink it though. Yes, that is also found there. Um, Sharp is asking which school that I teach. I teach at a lovely school in Montego Bay, a school that I went to myself. So I'm a past student plus a teacher there. Does mangrove only grow where the brackish water is? Pretty much yes, but you have different types of mangroves. There are some land mangroves, but those land mangroves that actually grow on the land with no water underneath its roots, those land mangroves, those are still close to the area where the sea would have been. So not all of them are actually inside the brackish water. So you have the black, the red, and the white, I think. Yeah. So it would just depend on where their specific niche is, where they survive best. All right. So somebody else is saying sea moss. Okay. You go to Ardennes. Oh, nice. That's a lovely school. Nice to have you, Sharp. Please ensure that you subscribe to the channel so you don't miss anything that we have going here. Other persons who are new, ensure that you subscribe as well. And check out the other videos and check out the other past papers. Go through them. You will see how much the questions actually repeat. And you will hear the explanations that we go through as to how you can answer the question, how you can figure out the best answer for the question, and how to eliminate, how to pay attention to the words that they have in bold to figure out how best you can answer your question so that you can get your best possible mark. All right. If you have any questions on what we have done so far, let me know. I have to end with you at 4 o'clock. And that is another 15 minutes away. So if you have questions, etc., just let me know so I can answer them before we go. I want to finish the physical section. I want to finish the physical section of the syllabus, and then we would move on to the human systems section. So, all right, so Tyrese has seen mangroves before. Very nice. All right. Hazards and natural disasters. So, the main difference between a hazard and a disaster is that one of them has the potential to create problems, and the other one has already created the problems. So, the hazard has the risk or the potential of creating problems. The hazard has the potential of becoming a disaster, but it is not a disaster yet until it actually happens. All right? The disaster now is when you have a natural hazard that has happened and it has negative effects on the environment. So, that is the main difference between your hazard and your disaster. If you understand that, just let me know so we can move on. But the main thing between the two is that hazard is just the potential for it to be problematic or disastrous, and then the natural disaster is the actual event that creates the actual problems. So that would have been your main difference between the two. For natural hazard, the syllabus asks you to look at risk resulting from processes associated with the lithosphere, biosphere, and atmosphere. When we look at those, well, we can look down here. Areas in the Caribbean or countries that are at high risk from hazards. So these are the hazards. Earthquake potential, hurricanes, all of us are, as well as the earthquakes, volcanoes, just some of our islands, landslides and floodings. So those are the hazards that are associated with the lithosphere, biosphere, and the atmosphere. Then we have natural disaster that we're supposed to look at. Effect of the event, which is the actual thing, on the physical and human landscape, especially in areas of high population densities. So for disasters, population density is important. So think about it. There's this thing that somebody said, somebody important and famous, said that if a tree falls in the forest, does it still make a sound? Something to that effect, right? Just work with me. You'll get what I'm saying. So, for that famous important person that said that, if a tree falls in the forest, does it still make a sound? It's kind of similar to disasters here. Because if you have a remote island that is off the coast of somewhere far, where you have no one living on it, or let us say you have one person living on it, and then that area did not have a lot of development and lots of things going on, the effect of the disaster would not be as dramatic as if you had the disaster in an area of a high population density. So the presence of people is very, very important when you're talking about the effects of natural disasters. So if you have a natural disaster on that remote island where nobody is, and let us say you had a earthquake, and the earthquake literally destroyed the island, and you had liquefaction occurring and things were just all over the place, and there was a lot of landslide and all of that was taking place, but nobody was there. That disaster would not be so disastrous because you did not have that high population density. But if you had that same earthquake in an area where you had a whole lot of people, for example, a city area that is very densely populated, you have, well, another thing with disasters, it depends on the time that it takes place. For still on earthquake, for example, if I don't want to use Haiti as an example, it is a very sad point for me, for the entire Caribbean, I think. But the time of a disaster is critical. I think one of the times for Haiti, it happened at 3 o'clock in the afternoon. So 3 o'clock in the afternoon would mean that all of your schools would just be out, and you would have children everywhere. Everybody would be leaving school. They would be on the streets, going home, in a taxi, waiting on a car, standing with their friends, etc. 3 o'clock in the afternoon, lots of people are at work, babies are at daycare, businesses are operating, lots of trucks on the road, etc. So a lot of things are happening at 3 o'clock in the afternoon. And in a city in the middle of the week, there's a question like that as well, a past paper question asking when, which one of these areas would have been the most densely populated, or would have more people in the middle of the day in the week, something like that. And you were supposed to choose the central business district, which is the city area. That would have been your answer. But the point I'm trying to make is, in a city, in the middle of the week, at like 3 o'clock, 4 o'clock in the afternoon, a whole lot of persons on the street. So when you have a disaster taking place at that specific time, it means that the effects of the disaster is going to be a whole lot more than it would have been if it was 2 a.m. and everybody was in bed and sleeping. So the time of the disaster is extremely important as well. Plus, the high population density is extremely important as well. So as a people, we tend to measure the effects of a disaster based on the amount of persons that died. So they will count up the death toll and say 100,000 people died. So that means it was very, very, very terrible. That would have been in an area of high population density. But if you had one person dying, it would seem as if it is not as terrible because only one person died. That's how, when you're looking at disaster and risk management, that's how it would be looked at, right? So natural disasters, you're talking about the effects of the event on the physical and the human landscape itself. So let us look at them individually. For hazards, for earthquakes, what are some physical damages that we would have seen for earthquake? And also tell me what are some damages that we would have seen from a hurricane, from a volcano, from a landslide, and from flooding. So just tell me those in the chat section. What are some of these things that we would have seen in our countries? So I can start off with hurricanes. I think at the moment there is a storm. I don't know if it's a storm yet, but we're expecting a storm probably in the next 5 days. They said that there is one out on the waters that is forming. So maybe in another 5 days we will be thinking about all that we were studying while it is happening. I don't know. So effects would have been how it affects people and their property. So one thing that you can always put for all of these, if you are asked to identify a effect of any one of these things, I'm seeing property destruction for earthquakes. I'm seeing landslides. I don't know, Tyrese. I have no idea. No idea at all. I'm seeing flooding as well. One of the things that you can put for any question relating to this is destruction of property, because that will always happen. That is always an effect. Another one that you can put is loss of life, always an effect, right? So loss of life, loss of property, loss of livestock. That's for the farmers. Loss of essential services. Very nice, Vickery. That's the first time seeing you. Hello, Vickery. You can also put disruption of the economy, because you know that you will have people that can't go to work anymore and tourists can't come anymore, etc. I'm seeing lots of good answers. Loss of arable land and infrastructure, loss of life again, flooding, etc. So all of these can give you those things. For earthquakes as well, you can put other things such as fire. That is a secondary effect of the earthquake. The earthquakes can pull down the power lines, etc., and then you end up with fires across different areas. You can end up with what again? Deforestation too from the landslides. So you may end up with a bare, very bare slope. So all of these can cause a lot of problems. So generally, all of what you just listed, all of the ones that you just listed can fit for these that we have here. Bacchus says Guyana flooding, not any recently or for years though. Okay. And tsunamis. We're seeing more frequent tsunamis. Once there's an earthquake out in the ocean, then naturally people start looking or expecting a tsunami to occur. Effects of natural hazards and the disasters. So based on all the effects that you just gave me, some can be short-term and some can be long-term. Short-term effects are the ones that we can fix really quickly. So we have disruption of some services, and these short-term or long-term is basically it basically depends on how bad the disaster was, because in some countries lots of essential services may be short-term, meaning they may be up and running again tomorrow. But in some countries, depending on how bad the disaster was, they may be out of these essential services for another year or another 6 months. So it really, really depends, right? Then we have, I think we covered all of those. Final one, we have responses of individuals, national and regional agencies to the risk of hazards and the effects of natural disasters in the Caribbean. All right, so Tyrone says, like when it's hurricane, JPS turn off the light. That is true. Yeah. So responses of individuals, national and regional agencies to the risk of the hazards and the effects of natural disasters. So how is it that individuals respond to these disasters? Let me ask first. How is it that we respond to a hurricane? What is it that we do as Caribbean people? Because we've had it so much, so we pretty much know that, all right, this is gonna happen, a hurricane is gonna come, we can predict it, the meteorologist tells us. What is it that we do as Caribbean people? How do we go about it? And that is us as an individual. What does your parent do in their home? What are you doing as a child in the home? Secondly, as a nation, as a country, what is it that you are doing? So I'm already seeing Jelan is saying evacuation. So it depends on where you live again, right? So you have an idea of what normally happens when a hurricane comes. So as a result of that, you would know that, all right, a hurricane is coming. It is category 5. I am expecting this area to be flooded. Therefore, I am going to pack my bags and I am going to leave. Olani. Hello, Olani Koipel. Nice name. I hope I pronounced it right. So you are going to stock up what you need. Stock up on tin food, canned food, okay? So you buy essential products, prepare by shopping for supplies. Chop down tree limbs from nearby houses, Board up windows and doors, stock up on essential goods, strap your roof. Very good. So you all have very, very good examples of what will be done before the hurricane. Listen to the weather forecast, stock up on supplies, gather all important documents. Good. So all of that, what you're telling me, is what we do to prepare for before the hurricane. What is it that we do during the hurricane as an individual? What is it that we do during the hurricane? During the hurricane, what is it that you're going to be doing? And then after the hurricane, what is it that you are going to be doing? After that, we're going to look at what the country does in general. As a nation, what is it that is going on? So some persons are saying stock up on, yeah man, lots of food. Everybody's saying food. We're stocking up on a lot of food. Nobody wants to go hungry. We're digging trenches to ensure that the water flows off the land and ensure that we have a supply of clean water. And okay, so for Liana now, Walrond, when you say stay inside, I'm assuming that you mean what we're going to be doing during the hurricane. So we're staying inside, we're staying close to a shelter, and we are staying safe, basically. Team Unknown is playing board games to kill the time. And after the hurricane, you clean up, you go and look for persons who may have been injured. You have a radio. This is during, you have a radio to stay informed, etc. Very good examples you guys have. As individuals, we have that covered. Now, as a nation, what is it that your nation would do? So it says, where are we? Response of individuals, then national, then regional agencies. So nationally, what is it that your government would do? Your government would probably tell you that you need to evacuate for some areas. They would also ensure that they keep you up to date with the news. They would also, well, I'm seeing Tyrone with more food. Again, look food after the hurricane. So, Deron is listening football on the radio. No, Deron, you need to be listening to the news to ensure that you're keeping up to date with everything that is happening. All right. For the country now on a national level, okay. So I'm seeing the Ardenite coming out with the ODPEM, that is Office of Disaster Preparedness and Emergency Management. They would be out on a national scale, ensuring that people are doing what they're supposed to do. So they do have some representatives in each parish. Each parish would ensure that they are following the protocols and they are keeping safe, etc. NEMO, I don't know what NEMO means. I figure it's one of those emergency agencies. You can just tell us. It looks like National Emergency Management Organization. I don't know, but just tell me. That's Veronique. Tell me what NEMO means. And then we have Red Cross, provide relief shelters, etc. All right. Government give a helping hand to the needy. Provide hurricane food packages. CDEMA. Okay. We have NEMO in St. Vincent and Grenadines. Yes. So what does NEMO mean? I still don't know. All right. So basically, the government would have general agencies that they use to assist the nation as a whole. Now, I see Tyree saying the nation can source finances from other countries to help in reconstruction. So now we are getting to regional agencies. I'll put regional and international together. So what is it that outside help can give to you? What is it that the persons outside of your country will do? So then you have the Red Cross people coming in, and then you have the, what are they called again? Somebody else. Give me an idea. I don't remember. Seek finances from other countries to help in reconstruction. Yes, so other countries will assist you with food. Red Cross would come across with food. You would have Food for the Poor would assist you with food and other essential items as well. So that is what the regional agencies would do. Not only that, not only on the individual level that they would help, they would also ensure that they lend the government some money or give the government some money to assist in the relief efforts. So NEMO means National Emergency Management. Oh, I was very close. National Emergency Management Organization. Another example I'm getting is UNICEF. All right. After the hurricane, if anyone gets hurt, the government should be aware and they assist these persons. Very good. Very, very good answers. So we would have covered, not in its entirety. This one, we did what the agencies would be doing. The next part of it is the stages in the hazard disaster management cycle. Now, there was a time when the syllabus was split into 4 sections, and this would have been under human environment systems. It is under this section that we would actually be looking at this, but now it is under natural systems itself. So another example is that we send specialist persons such as paramedics, soldiers, essential workers. I'm assuming that we'd send them to the areas where they need assistance. So the final one is the stages in the hazard disaster management cycle. Now, do you know what the cycle looks like? I'm assuming that you do because you would have done this at school already. So we would have the pre-disaster stage and you have the post-disaster stage. Then you have, let us look at the pre-disaster stage first of all. That is, what is it that would be happening before the disaster happens? So you would have, in pre-disaster, you would be trying to prevent it from being bad for you. That's prevention, then mitigation, then preparedness. So you have prevention, you're putting in some action so that it doesn't impact you so severely. So that is for the persons who would be battening down their roof. Then mitigation, action to prevent property damage and minimize economic impacts. And preparedness, action to increase their capacity of a community for prompt and efficient response. Then now, you have the disaster impact. So the disaster happens, then you have the post-disaster. What is it that you do after? So you have the response. So you would have all those persons who are already trained from all of those organizations that you spoke about. Those persons who are already trained and they're experts in their field. They have some emergency response teams. So if they heard that there's a landslide there, they would ensure that the fire department is there to get those people out, etc. Recovery. This is the action to assist communities or the nation in general to return to normalcy, to return to that pre-disaster level, what they were like before the disaster happened. So this is where a lot of the international agencies may come in, where they assist you as an individual or as a country to get to a point where you are back to normal functions. So they may assist the government by giving them some money. They may assist community persons by giving them clothing or food, depending on what was lost. So they're bringing you back to what you normally were like. And then finally, you would have been back at your redevelopment. So you cut your losses. you move on and you have rebuilt, you have redeveloped, and basically you sit down and everything is going normal, and then you wait until another disaster is coming, you go ahead with more prevention, mitigation, preparedness, etc. Okay, so that is basically what would happen for the disaster management cycle. If there are any questions, let me know. I did say I had to leave at 4. It is now 4:12, so I do have to go. Yes, Tyrone, they would clean the road because you may have landslide, areas may be blocked, wires may be down that they need to ensure that they pay attention to. Right. So we are at the end for today. There's a section of right. So the next time we have this live crash course, it is going to be for human geography. So hopefully we can finish human geography in 2 days, just finish going through everything. Then we can jump into the map work section, and then we can run off map work in another 2 days, and then we can move on and finish up all the past papers before your exam, which is the 15th. Right? So we want to get all of those done and out of the way before your exams. So the next live will be crash course for human geography. Again, if you're not following the Instagram page, ensure that you do so, because that is the first place that I would post what time the live is, what day it is happening, etc. So you will get a heads up. I see somebody's asking when is the next class. I'm hoping for tomorrow, Olani. I'm hoping for tomorrow, but I am a teacher and I am in charge of my grade 11s. So, it's almost exam time, so there's always something to do. So I can't give you a specific time, but ensure that you subscribe to the channel and turn the notifications on so that once I start a live or I set one up, you'll get a notification, and then we will wait around for another little 10 minutes or so until most persons get on, then we will start so that you won't miss anything. Okay? 2006 past paper, I am gonna do it. I already have it and all, but I want to just run through the human side of geography first, and then we can move right back into the past papers. Yeah. Thank you, Jelani. Yes, Tyrone, I know you're going to make me so proud. I'm already proud. I can see a lot of growth in you guys. I can see how you're answering your questions faster. I can see how you're getting a lot more of them correct. So that is just wonderful. And another thing, if you're not a part of the Geography online community that was created with Discourse, ensure that you join. I must say big shout out to Vedish. He has been setting up Zoom sessions, Zoom meetings, and then the other persons would just join the Zoom meeting, and then they just discuss geography, past papers, etc. for the entire time. They had one yesterday, they had one this morning as well. I did not join, but I think that it went really well. They let me know when they had ended as well. So you can just join the online community. It's free, doesn't cost you anything. You can just send in your past paper questions, anything like that, and someone will be there that will answer you and assist you. If you're not on Instagram, you can follow me on Twitter. I normally post the same thing on both places, and if you're not there either, I also post the same thing on Facebook. So once I drop it on Instagram, it is posted on Facebook and on Twitter at the same time. And everything for me is Natken Educational Services. So you can just search that and then you will find it. Again, if you have any other questions, you can send me a message. You can send me a DM on Instagram, or you send me a message on Facebook or on Twitter. All right. Thank you so much for joining. Again, it was my pleasure to assist you. It's always a pleasure. Have a wonderful evening. And I will save this. I'll put this, save this live so you can get to review it. All right. Bye, guys.